Hello, I'm Floyd Maxwell, justthinkit.com. This video is called Consequences of a Spring and Loop Theory, Diffuse Interstellar Bands. Headline: Mysterious molecules in space. Scientists here on Earth should be able to use spectroscopy to identify those interstellar molecules by demonstrating which molecules in the laboratory have the same absorptive fingerprints. But despite decades of effort, the identity of the molecules that account for the diffuse interstellar bands remains a mystery. Nobody has been able to reproduce the exact same absorption spectra in laboratories here on Earth. This talk won't be easy. Actually, it's trivial, so it won't be easy. There's no such thing as a problem which is other than merely conceptual. Ramesh S. Balsekar. Conundrums are good. Try this simple quiz. Did you graduate from high school? Yes? Okay, you're part of the problem. Go to line 10. No? Go to line 20. Line 10. Public school education equals same as everyone else's vacation. Stern voice. You have 6 months to live. Others determine our fate when we let them. So first you need to stop letting them. Press any key to continue. Good. Next you need to scrub your memory. Oh, this won't work if you went to college. Sorry. Have patience with everything in your heart and try to love the questions themselves as if they were locked rooms or books written in a very foreign language. Don't search for the answers, which could not be given to you now because you will not be able to live them. And the point is to live everything. Live the question now. Perhaps then, someday far in the future, you will gradually, without even noticing it, live your way into the answer. Rainer Maria Rilke. The child test. Take the following instructions to the nearest 6-year-old. Okay, anyone younger than 9 and older than 2. Your mileage may vary. Drum roll, please. Sung to the tune of Soylent Green is People. Diffuse interstellar bands are ripples. Well, technically they are ripples upon ripples. Upon ripples. Lab coat time. Spring and loop theory's first experiment. At your nearest pond or lake, or open stretch of ocean if it is unusually calm, bend over, grab a handful of rocks in each hand, both of you, or all three as a crowd. Then, one handful at a time, throw your rocks into the water. This is the tricky bit. You need to throw all rocks in the same general area of the pond or lake, pausing just a moment after each throw. You may need to practice your timing to master the just a moment part. Observations. Now bring out your clipboard and a crayon. You don't have a crayon? Not good. This won't work without a crayon. Got one now? Okay. Record what you see. You can even make a drawing if your crayon is sharp enough. Results and conclusions. So, what do we have here? We have mixing. Wave mixing. But also something way cooler. We have new waveforms. Ode to Hair. Did you hear music? I definitely heard music. Is this the dawning of the age of a zodiac sign? And any chance you also saw a light bulb? Fluorescent or light emitting? Time for some big boy physics. Okay kids, time for the grown-ups to talk, so they can catch up to you. Now about these new waveforms. Is this a big deal? Yes, because fail. Temp theories expect sameness. You can't build a house of cards if some of the cards are different. And what if the cards get wet? Then you get unemployed physicists. Headline: Strange X-ray signals from Perseus and Andromeda galaxies may be dark matter. All atoms are known to emit a distinct pattern of light known as spectrum, and this is how scientists are able to know what celestial objects such as stars and planets are made of, even from great distances. While studying the spectrum from the Andromeda galaxy and the Perseus galaxy cluster, however, the researchers have detected spikes where nothing should exist. Because the signal does not correspond to any known particle or atom, the researchers suspect it may have been produced by dark matter. Impermanent fabs. I wonder how often Intel has had to change its core assumptions. Techniques that worked at one atomic level simply stop working at the next level smaller or larger. With billions of dollars on the line, desperation sets in, and back to the drawing board they go. What to do? If only physicists would go back to the drawing board. Kinda hard for most to do that when they have shut the only door that leads to the exit. Or is that an entrance? Etherize already. Okay, I'll say it. Ether. Ether, 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 ether. Ether. It was highly honorable of his logical conscience that Newton decided to create absolute space. He could just as well have called the absolute space the rigid ether. Albert Einstein. Cathartic, wasn't it? If light photons are particles, they can't become something else. If light photons are bumps, they can be constructively or destructively bumped into a new type of bump. Like getting upgraded to first class on that flight to Reno. Presto changeo, 10 feet off the ground. Wheels within wheels. A ripple added to other ripples produces totally unique ripples, like snowflakes, and new governmental restrictions. Headline: Map of mysterious molecules in galaxy sheds new light on century-old puzzle. Astronomers from the Sloan Digital Sky Survey have created a unique map of enigmatic molecules in our galaxy that are responsible for puzzling features in the light from stars. These puzzling features, which astronomers call diffuse interstellar bands, or DIBs, have been a mystery ever since they were discovered by astronomer Mary Lee Hedger in 1922. Further research showed that these mysterious lines were caused by a variety of molecules, but exactly which of the many thousands of possible molecules are responsible for these features has remained a mystery for almost a century. Milking this thread. For those who need a more precise explanation, that is left as an exercise for the reader, and as a sword to the heart of those bilking the public purse for physics research dollars. The Daffy Dib Detector. Sorry, I pictured the headline, 200 million set aside for dedicated dib detector, and couldn't let that money train leave the station. So how bad is it? Let's delve a little deeper into what we know. Well, that's easy. Almost nothing. The Wikipedia page for this 100-year-old problem contains just 9 references. The 2005 entry, the most recent, is mere cataloging. Clearly, temp theories haven't got a clue. A head-to-head comparison. This 2013 article at least asks the right question. Will we ever solve the mystery of diffuse interstellar bands? There are dark lines in space and they hide in the light. We've known that they're there for nearly 100 years, but we still don't know what they actually are. All we know is what we call them, diffuse interstellar bands, and that they mean that something is out there in space that we haven't identified. In the 20s, Mary Lee Hedger spotted the first example of what has become an enduring mystery. She noticed that a binary star system's spectrum of light, the rainbow-like range of wavelengths of light emitted by bright objects, had gone dark in a couple of places. This wasn't unusual. These were absorption lines. Certain atoms or molecules absorb certain wavelengths of light, while letting other wavelengths through. These absorbed wavelengths show up as dark lines on the continuum of color in a spectrum. What was unusual was these lines weren't shifting. Generally, in a binary system, the stars are moving toward and away from the viewer on Earth. As they move, their spectrum lines shift, much the way the sound of a car horn shifts if it's moving towards or away from you. These lines weren't shifting. In itself, this means the lines are caused by and originate from the ether. After some analysis, it was discovered that the lines weren't shifting because they came from material that was between the stars, not part of them. But to this day, no one has been able to lock down what exactly these lines are. You mean they must be between the stars to fit in with temp theories. The absorption lines, called diffuse interstellar bands, or DIBs, pop out all over the electromagnetic spectrum. But good luck trying to find a list of all DIBs. Clearly, research is at a standstill. All we see, everywhere, is an unlabeled Wikipedia graphic. Pretty pictures do not a science make. There are hundreds of them in space. Generally, this would be helpful information. Except when temp theories are wrong, like in this case. These lines are different. Scientists think these absorption lines are the sign of complex molecules, but nobody has found any that can exactly correspond to the DIBs. So what could the DIBs be? We don't know. All we know is they're definitely up there and they're dark. Of course, they don't know any of this. Temp theories desperately hope they are up there. A more honest statement? Number 1, something is causing something. Number 2, the existing mainstream physics theories haven't got a clue. And number 3, spring and loop theory does. This hilarious story appeared just as I finished COASALT DIBs. old astronomic riddle on the way to be solved. Their guess? Positively charged Buckminster fullerenes. Quoting from the story, the spectrum measured in the lab did show absorption features at 2 out of 400 wavelengths that were near to DIB that had been discovered by astronomers the following year. So if they were discovered, quote, the following year, quote, then they are new DIBs that must be extremely minor to have taken 100 years to be noticed. This is the kind of thing that is created and then found. That's always a fun way to find something significant, make it up, and then look for it. Even if one tries to make this appear meaningful, it would require nature to create whole bunches of Buckminster fullerenes, with the odds of this happening by chance about the same as a million monkeys typing up every work of temp theories. Wait, was this article published the following April 1st? Footnote. Scientists discover route to creating buckyball. In a significant first, Professor Lawrence Scott and colleagues have devised a 12-step route to create C60 buckyballs in the lab from readily available materials. Collecting buckyballs has been an inexact science that has required vaporizing a graphite rod with a laser or an electric arc and picking up the pieces. Until now, scientists haven't been able to synthesize Buckminster fullerenes from start to finish in the lab.